This is 7.6 of Algebra. So we're going to work with exponential functions. So far we've worked with linear functions, okay, straight lines. Now we're going to work with exponential functions which are curved, as you can see here. The general form is y equals a times b to the x. Sometimes the a is just a 1, so it's y equals b to the x, but that's our general form. There's two different pictures here. I want you to pay special attention to the red lines, okay? In this one, you get this sort of shape, so starting small and getting big, when you have y equals a number to the x, okay? Where the number is bigger than 1. Over here, you get it where you start big and go small, and that's y equals number to the x. Where the number is smaller than 1 and it's positive, so it's bigger than 0. Usually, so this is going to be like a fraction or a decimal. Okay, so linear, when we had something like this, y equals 2x plus 3. If I make a table, if I plug in 0, I get 3. If I plug in 1, I get 5. If I plug in 2, I get 7. If I plug in 3, I get 9. So whenever we're looking at pretty much any equation, your x's should be going up by the same amount. So usually adding 1 or adding 2 or adding 3, that sort of deal. But you want it to be the same so that you can actually make a conclusion from how your y's are going up. When we're working with linear equations, we are adding. Okay, so in this case, we're adding 2. Okay, so linear deals with adding. Whereas when we're working with exponential, we're working with multiplying. So let's look at our two examples down here. So first, let's look at this table, okay? So we want our x's to be going up by a consistent amount, by the same amount each time. In this case, we're going up by 1s. So we're good there. Down here, so I want to look at what the difference would be if I'm adding, but also if I was multiplying. So to get from -1 to 1, that'd be adding 2. If we were looking at multiplying, that would be times -1. -1 times -1 is equal to 1. Because when you look at two different numbers, you can figure out adding and you can figure out a way to get it with multiplying. It's when we look at the next pair that we're going to be able to tell, is this linear or is this exponential? So if we're adding to get from 1 to 3, that's adding 2. If we were multiplying, that'd be multiplying by 3. So the thing that's the same is the adding, so this must be linear, and we're adding by 2 each time. So this one is linear. This equation, because the exponent is a variable, is exponential. Okay, I want to show you a few other equations. Y equals 3x plus 6, that's linear, right? That's just a line, that's stuff we've been working with before. Y equals 2 to the third plus 3x. This one has an exponent in it, right? There's a 3, that's an exponent, but it's not a variable, right? The variable's down here. So this is still just linear. So when we're working with exponential, the variable is the exponent. Okay, so now we're going to plug into an equation. So we're given this function, f of x is equal to 20 times 3 to the x. Okay, so this is talking about, it says an initial population of 20 rabbits triples every half year. So the function f of x equals 20 times 3 to the x gives the population after x half-year periods. How many rabbits will there be after 3 years? So our x needs to go in half-year periods, but the x that they want us to plug in is 3 years. So I can't just plug in 3 for x, okay? Currently I've got 3 years. I need to put that into half-year periods. So half year, 6 months, right? Each year has 2 halves. So the first year there's 2 halves. Second year we get another 2 halves. Third year we get another 2 halves. So this is 6 half-year periods. So I'm going to plug in 6 for x. So f of x is equal to 20 times 3 to the 6th. Oh, and we can plug in 6 in our function notation as well. So f of 6 is equal to 20 times 3 to the 6 is 729. And then when we multiply by 20, we get that f of 6 is equal to 14,580. So after 3 years, there's almost 15,000 rabbits, which is pretty crazy. Okay, now we're going to work on graphing an exponential function. I just want to do this first one. What we're going to do to graph these is we're going to use a table to figure out some points and then graph it. I'd suggest that you use the points they do. So -2, -1, 0, 1, and 2. That's just a good view of the graph. So x and y, plug in -2. Well, that's y equals 0.5 times 3 to the -2, which gives us about 0.06. And I'm going to plug in -1, so y equals 0.5 times 3 to the -1, which is about 0.17. When I plug in 0, we get y equals 0.5 times 3 to the 0. Anything to the 0 is 1, right? So this is 0.5 times 1, which is just 0.5. I'm going to plug in 1. We get y equals 0.5 times 3 to the 1. That's 1.5. And finally, if I plug in 2, I get y equals 0.5 times 3 squared, which is 4.5. And then I'm going to graph this. So -2, -1, 0, 1, and 2. So at -2, I'm just barely above the line. At -1, I'm a little bit more above the line. At 0, I'm at 0.5. At 1, I'm at 1.5. And at 2, I'm at 4.5. So you're not putting in a straight line, remember, you're making a curve. So attempt to make a good curve that fits that. Also, this will never hit the x-axis, okay? So you don't ever cross the x-axis. It doesn't ever get to 0. And there you go. Let's try graphing with a story problem, okay? So we're going to use this equation, f of x equals 100 times 4 to the x. Okay, and we're talking about a map and zooming in. So, f of x is equal to 100 times 4 to the x. Since we're talking in real life situation here, we're not going to use negatives. So, x and y, I'm just going to start at 0. Let's just do 0, 1, 2, and 3. How about your choice on exactly how many you'd want to do. So, 100 times 4 to the 0. Well, anything to the 0 is 1, so that's just 100. 100 times 4 to the 1. That's 100 times 4, so that's 400. 100 times 4 squared. That's 16 times 100, so we get 1,600. Then 100 times 4 to the 3rd. That's 100 times 64, so that gives us 6,400. So the biggest thing is that your units are going to have to, you're going to adjust your units based on your points. So we just need 0, 1, 2, 3 on our x-axis. I need to get up to 6,400. So I'm going to go up by about 500s. So 500, 1,000, 1,500, 2,000. I'm actually just going to skip up by thousands. So this would be 2,500. So this is 3,000. This would be 3,500. So this is 4,000 right here. And this is 5,000 right here. So this would be 6,000 right here. So this would be 6,500 at our top. Okay, so at a 0, I need to be at about 100. That's about there. At 1, I need to be at 400, so about there. At 2, I need to be at 1,600. So that's about there. And at 3, I need to be at about 6,400. So that's about there. And then again, I'm going to connect those. Just like that. Okay. Solving one variable equations. If you have a graphing calculator, you can do this on your graphing calculator. If you don't, I would suggest that you use Desmos. It's an online graphing calculator. So we want to know, when does 0.3 to the x equal 5? Okay, we can't just divide by 0.3. We can't subtract 0.3. So what we're going to do is we're going to graph this. So we're going to make two different equations. One is y equals 0.3 to the x, and one is y equals 5. Okay, you're going to get an equation from each side, and you're going to graph that and find their intersections. Okay, so figure out where they cross. Sometimes they're going to cross once, sometimes they'll cross twice, okay? And whatever the x value is, that's your answer. So when I graph this, I get that they intersect at the point -1.337, comma 5. The only thing I care about is the x value. So my answer is that x equals -1.337. So we can do it again with this one. Remember, you get two different equations. Y equals 1.25 to the x, and y equals -2x. And when I graph that, I get that they intersect at the point -0.452, comma 0.904. So my answer is just my x. I don't care about the y. X equals -0.452. And if I do my last one of my equations is -2 to the x. Make sure you've got your parentheses around that. So y equals -2 to the x. And this gives me y equals 3/4 x minus 4. And when I graph those, I get that they intersect at the point 1.52, comma -2.86. So again, I just care about the x value, and I get x equals 1.52. And there's your homework.